Look at the question here. I want the polar compound and the central atom of that particular polar compound need to be sp2 hybridized. When I will take up the first part, it's carbonic acid. When I will write carbonic acid, I know H is +1. When I will take H is +1, 2 into +1, altogether it become +2. When that is +2, carbonate become -2. Clearly I can see polarity. So I am saying that it's a polar compound, right? Now when you look at the carbonate radical, it's CO3 -2, oxygen divalent 1 and 1, 1 and 1 is 2. Look at around carbon, how many bonds sigma present. You have 1 sigma, 2 sigma, 3 sigma, 3 is 1 and 2. So it is sp2 hybridized. So option A, let me keep it as answer. Let me look at the option B. So we have Si F4. So if you want Si, group 14, so 4 valence electron, let me show you. We have 4 fluorines. Fluorines are monovalent. We all know that. So we have a 4 bond pair and no lone pair. I know SiF4 like a CH4, 4 hybrid orbital. It has a tetrahedral geometry. Let me show you people the tetrahedral geometry. First of all, you have 4 bonds. 1 and 3, it is sp3 hybridized, cannot be the answer. Look at option C, boron in the center, group 13, 3 valence electron. We have 3 fluorines, monovalent atom. We have a 3 bond pair and no lone pair. 3 bond pair means we have a trigonal planar geometry. So you look at the trigonal planar geometry. 3 bonds, 1 and 2 is sp2. Look at here, fluorine electronegative, positive, electronegative, positive, electronegative, positive. Look at these two dipole moments, their resultant will be here. And look at this particular dipole moment, it is still here. Because it is pertaining to BF, even it is pertaining to BF, their magnitude is same, the direction opposite, so they cancels out each other. So net dipole moment value becomes equal to 0. Because net dipole moment value becomes 0 here, it cannot be polar. It is non-polar. So even option C we are ruling out. So we are left with the option D here. So let me show you. Chlorine in the center, you know there is a HO2. Let me tell you, it's a derivative of chloric acid. You know that at the top we have perchloric acid, then chloric acid, then chlorous acid. Fine. So Cl in the center, 1H indicate 1 OH. So 3 more O yet to be written. Oxygen divalent, let me show you. When you are coming down, 1 O becomes less. I can see that. When you come down still, 1 more O goes out. So this is what? Perchloric, chloric, chlorous acid. This is chlorous acid. Now first of all, you see around carbon, how many sigma bond you have? You have 1 and 1, 2 sigma bond you have. The central atom chlorine, it has got 7 valence electron. I can show you 1, 2, 3. So 4, 5 and 6, 7. Correct. Now you see sigma 1, sigma 2, 3, 4. 4 is 1 and 3. It is sp3 hybridized. We want sp2, right? Even this cannot be the answer. So option A, as initially I told, this is the right answer.